Hello everyone. Today I'm going to show you how to build a simple image classification model and deploy them using Flask and create an REST API for the same. Here we'll be using Tensorflow 2.0. So let us begin by opening the Sublime text. So now in this tutorial we'll present a simple method to take a TensorFlow 2.0 model and deploy it in REST API. Here you will be learning how to load a TensorFlow 2.0 model and perform inference, create a API endpoint using Flask web framework and make predictions to the model, and then you will be using curl and Python to call upon the REST API. First let us import TensorFlow, import TensorFlow as TF. Before that we'll save our file somewhere. Documents, yes. Now we can say keras.py, replace the file. Yeah, so we are done with this. We have saved the file. So next what we'll do is we'll first think of uh, functions that we'll be using. We'll be mainly using three functions: one to load the model, and then to prepare the data set, and a prediction function. So for this we need PIL library because we'll be importing the image in PIL format, and we also need numpy as in and we need Flask web framework. Import Flask and then import input output library. So later we have to initialize our Flask application as dot Flask model equals none. So here in the first code snippet, what we are doing is we are importing all the necessary library, and then now what we'll do is we'll define a function load underscore model. This method is responsible for instantiating our architecture and loading the necessary weight. Here we'll be using ResNet 50 architecture, which has been pre-trained on ImageNet dataset. If you want to use your own custom model, then you'll have to modify the function such that you load your own architecture and weights. So let me define the function load underscore model, and then we say global model, as we'll be calling this in different functions. Model equals tf dot start applications import as sorry tf dot keras dot applications dot as net 50 and weights equals net. So we have completed loading our functions. I'm not adding any doc strings. So next we'll prepare the data set. So here what this function does is it accepts an input image and converts it into RGB. Also it resizes the image size into 224 cross 224 pixels. This is the input spatial dimension for ResNet, and also pre-process the array via mean, subtraction and scaling. So let's define the function. Define prepare underscore dataset. So here we have image and target as arguments. So if image dot mode not equal to RGB, then image equals image dot convert RGB. So now we'll have to resize the input image and pre-process it. So to do that, what we do is we say image equals image dot resize target, and image equals df dot around dot preprocessing dot img underscore to underscore array image, and then we say image equals mp dot expand underscore dims dimensions is equal to image access equals 0. So image equals, and what we do is we need to do pre-processing. Here dot keras dot application applications dot pre-process underscore input, and we say image. So then we return image. So we now have completed the function prepare dataset. So we should again modify this function based on any pre-processing, scaling, or normalization, and we need to prior to passing the input image to the model. So now we are ready to define the predict function. This method processes any request to predict the endpoint. The data dictionary is used to store any data that we want to return to the client. Right now, this includes a boolean used to indicate if prediction was successful or not. So now to check the incoming data, what we do is we have a request method. The request method is post, enabling us to send any arbitrary data to the endpoint, including images, JSON, encoded data, or anything. So then an image has been passed into the file attributes during the post. So after this we then take the incoming data, read it in PL format, pre-process it, pass it through our network, loop over the results, and add them individually to a list that we define inside this function, and then we return the response to the client in JSON format. So now that's the whole idea. Now let's start building this. We have add app.route, and then we'll have a predict, and then the method is post. So the request method is post to send us any data to the endpoint. Now we'll define the function predict. So here we'll be initializing the data dictionary data. And we say if flask dot request dot method equals post, then oops, and if class dot request dot files dot get image. So we then read the image in PAL format. Image equals class dot request files image dot read. Bytes IO image. So we are now reading the image, and then we'll pre-process the image and prepare it for classification. Image equals prepare so we have defined prepare data set earlier. So we say prepare underscore data set, and arguments would be image with the target is equal to 224. Here 224 and 224 the image size is because ResNet accepts a spatial dimension of 224 cross 224. We then classify the input image and then initialize the list of predictions to return to the client. So EDS equals model dot predict image results image net decode image. We have to see clear dot class clear dot class dot applications. Sorry, TensorFlow 2.0 requires some tf.keras.applications. Image net image net underscore utils decode underscore predictions. And then we set the variable that we have defined earlier. Then we create the list predictions. Then we loop over the results and add them to the list of returned predictions for image net ID label result so R equals label, creating a dictionary, comma probability so, and then we say data predictions that append or we now indicate that request was a success. Data equals true, and then we return the data dictionary as a JSON response. So we'll be returning the data basically as a JSON response, JSONify the data. So we have done all these. We have now finished off with the predict function, and now the last thing is to launch our service. So first we'll call the load model, which loads our TensorFlow 2.0 model from the disk. The call to load underscore model is a blocking operation and prevents the web service from starting until the model is fully loaded. So a request is posted to the server. The server accepts the request, preprocesses the data, and then attempts to pass it into the model. So, but since the model isn't fully loaded yet, our script will error out. So now what we have to write a constructor here. Name equals name print loading keras. Then load underscore model, then app.run. So we have now finished with this. So now we have to start our TensorFlow 2.0 REST API. To do this, I'll go to terminal and then say cd documents, cd keras, and then I'll say python keras.py. So yeah, okay. Small brackets is missing here. Have some errors. We have an error. It says got an unexpected argument method. Here, method is post. Sorry, this must be methods. So now the class is loading, basically TensorFlow 2.0. We are now downloading the data. So now we will be using curl to test the keras API. So we'll have to download some image, download a cat image. save save image as, and then so yeah, now the server has started. If you open the server, it won't have anything because we haven't built any front end. So let's see, if you say, if you open it, it will say, sorry, sorry. It says not found because we haven't built any uh, UI for this. So instead, what we'll do here is we'll use curl. So go to open another tab in the terminal, and then we say um, curl x post. Post is the method that sorry, we talked about post earlier, and then we say image equals cat, sorry, cat jpg, and then we will use endpoint predict. Then we'll see. So it's giving some error. Let's see. Server unable to complete the server, or there is an error in the application. Okay. Okay, we have an error line 32. It says, okay, so yes, now it should work. Again, it should. If we have corrected it, we'll restart the servers again. Python keras.py. It's loading now. So we'll again run this. Um, I think there's so many syntax errors. I think it should work now. Yeah, these are common mistakes that we make. So you can also learn from this. Run the file again. We had some errors, so corrected them. There was some issue with my TensorFlow version. So use the curve and see and predict the cat image. Now we are getting a label. It says Egyptian cat with a probability of 53%. This is it. I'll share the code in my GitHub and share the link below. Please subscribe to my channel for more updates on machine learning. Thank you.